What we are seeing here is the infeed material for the polycrack process. For the polycrack process, the infeed material could be all kinds of waste plastics. It could be waste rubber material or even organic waste. Any waste is good enough to be processed by the polycrack process. These plastics containing HDPE and polypropylene and some ABS material and also electronic plastics. And this material is even consisting some metal parts like the springs and some parts from the compact discs and also some tape. So it doesn't really matter what kind of plastic that is available to us. Plastic need not be segregated, no material needs to be segregated. Unsegregated plastic waste of mixed plastics, including electronic waste plastics, can be processed by the polycrack process, and I will show you the process now. What you are seeing here is the feed hopper for the waste plastic that is to be fed into the polycrack reactor. The plastic is then conveyed into the reactor. The conveyor actually transfers the material into the reactor inlet, which can be seen at the top. What you are seeing here is a polycrack reactor. Polycrack reactor is a horizontal rotating type of a continuous basis reactor where the feed material is continuously fed into the reactor and it is processed. The reactor operates 24/7 and it is a continuous reactor. That means there is no stoppages for the process at any given time. The temperature inside the reactor is maintained around 450 degrees centigrade. At this temperature, the plastic material or the rubber material or even the organic feedstock, they get converted into vapors, and these vapors are converted into a catalytic converter in the reactor. By the time the feedstock material reaches the end of the reactor, it is already in a vapor phase. What happens is that by the time it reaches the end portion, the material gets split into two parts, a vapor phase part and a solid phase part. The solid phase part is essentially carbon, and the carbon gets collected into the carbon receiving vessel. Whereas the vapors, they are actually transferred into a catalytic converter which is shown on the top of the reactor right at this point of time. And in this catalytic converter, many reactions take place. And one of the reactions is depolymerization, where the polymer gases are converted into monomers. And the second reaction is basically cracking. A catalytic cracking of these monomers happens and basic hydrocarbon vapors are generated in the catalytic converter. In the third function, the catalytic converter reforms them and creates the middle distillate level of molecular structure, which is equivalent to the gasoline, kerosene and the diesel fractions of a hydrocarbon chain, which we essentially call them as light diesel oil fractions. So these light diesel oil fractions are then converted into a condenser. So now you are seeing in the catalytic portion here that splitting into two parts, a solid part which is carbon and a vapor phase which is essentially a hydrocarbon vapor. The residual carbon coming out of the reactor is hot when it is exiting the reactor, and it is collected in the carbon receiving vessel. Because it is hot and if it is exposed to the atmosphere, it will turn into ash. In order to prevent it from turning into ash, we have to cool the carbon. What you see here is a cooling conveyor which actually cools the carbon into ambient temperature. The carbon is collected inside a carbon collection pit, and at this point of time, the carbon is bagged and it is sent to the transporters for further disposal. On my right, what you are seeing is a gas tank where the non-condensable gas is collected and the gas is utilized to run the entire process. And the non-condensed gas is the energy source for the entire polycrack process. As you see here in the flare is a very nice blue flame which shows a very good combustibility and also a high calorific value of the gas. So this gas becomes an energy source for the entire process. So the process becomes energy efficient and energy positive. Typically when you are running the process, there is always some excess gas that is available after we utilize the gas. That excess gas is combusted and it is flared. Also, the material that actually the vapor that get condensed into liquids, they are collected as liquid fuel in the collection tank and the fuel collection tank on my right. This fuel tank actually stores the LDO, light diesel oil, coming out of the process, and it is a commercial product that is sent to the transportation. What you are seeing is the flammability test for the polycrack fuel that has been recovered from the polycrack unit. This is the light diesel oil. It has got a very good combustibility and it catches fire very easily, and it is burning steady and very nicely. So it's a very good fuel for industrial purpose.